Hello students, welcome back to JCE Connect series of lectures. So in previous class we have discussed how the hydraulic coefficients can be calculated by using a jet measurement method, that is experimentally, that is CV, CC and CD. So in this particular session I will be discussing about mouthpieces. As you know, the orifices, that is orifice is nothing but an opening which could be of any shape. It could be a circular, rectangular, square, triangular shape. So just the extension of orifice, what we call as a mouthpiece. Okay, so what do you mean by mouthpiece? A mouthpiece is a short tube of length not more than 2 to 3 times its diameter. You can see here this tube represents the mouthpiece. Just I'll highlight here. Just look at this tube. Just it's an extension of orifice. This is orifice, and orifice will be in flush with the tank, that is a bottom opening, or it is made on the side of the tank. So here a mouthpiece means a mouthpiece is a short tube of length not more than 2 to 3 times its diameter, which is fitted to a circular opening or a orifice of the same diameter provided in a tank or vessel containing fluid, such that it is an extension. See, very important. See, it's an extension of the orifice and through which also the fluid may be discharged. Means earlier means the orifice, when we were discussing about orifice, it was just an opening provided on the bottom of the tank or at the side of the tank, and it is in flush with the tank, this orifice. But the extension of orifice, the orifice will be extended like this. The extension of this one, what we call as a mouthpiece, it will be like this, mouthpiece. This is mouthpiece. Okay, so this length of the tube, you can take the length. This length of the tube will be 2 to 3 times its diameter, means the diameter of the orifice. If it is rectangular shape or the square shape, it can be taken as a depth. Okay, 2 to 3 times its diameter, which is fitted to a circular opening or orifice of the same diameter. So it is called as a mouthpiece. So this is also used for measuring the discharge through a tank. Okay, so here it is written a mouthpiece, or it is called as a tube. A tube or a mouthpiece is a short pipe whose length is not more than 2 to 3 times the diameter. Okay, so there is no sharp distinction, means there is no sharp distinction between a tube and a thick walled orifices. A tube may be uniform diameter or it may be a diverge. So it means it could be a uniform diameter or diverge. Okay, so here some of the examples showing these pictures. So here it is a cylindrical shape. This is also cylindrical. This is also cylindrical. Okay, so these are called as a mouthpieces. Next, so there are different types of mouthpieces here, and these are classified based on the shape of the mouthpiece, means according to the shape of the mouthpiece, what are the classification, and according to the position also the mouthpieces are classified, and according to the nature of discharge also the mouthpieces are classified. So according to the shape, if you take the mouthpiece is a cylindrical mouthpiece, means it's a uniform diameter, and convergent mouthpiece, convergent divergent mouthpiece. So these are the 3 classification made based on the shape. And if you take according to the position, means where the mouthpiece is been fitted, internal mouthpiece and external mouthpiece. I'll tell you what do you mean by internal mouthpiece and external mouthpiece. And according to the nature of discharge, mouthpiece is running full, mouthpiece is running free. Okay, so this is called mouthpiece. Okay, now, so what do you mean by external mouthpiece? So external, see, look at this picture here. It is a tank which is having a mouthpiece at the bottom or on the side of the tank. External mouthpiece, an external mouthpiece is attached to the vessel such that it is projecting outside. Means if the mouthpiece is projecting outside the tank like this, it is made like this. If it is projection is outside, it is called as external mouthpiece. So it is projection is outside, so the water is entering into this mouthpiece and it is discharging like this. Okay, this is called external mouthpiece. The equation for this external mouthpiece, as we know, the equation Q equal to A into V, the discharge equation, where V is the theoretical velocity and A is the area of the mouthpiece, and the area of the mouthpiece to be calculated, and A into V gives you the theoretical discharge. If you multiply it by CD value, coefficient of discharge, then we get the actual discharge. Okay, then convergent and divergent mouthpiece like this means initially the area is reduced, then it is expanding like this. Okay, so initially it is converging, then it is diverging, and it is called convergent and divergent mouthpiece. Means convergent divergent mouthpiece which converges up to vena contracta and then diverts. Up to vena contracta it converges, means the that is area of entry for the liquid will be very narrow, then again it diverts, means expands. That is what we call as a convergent and divergent mouthpiece. As we know the vena contracta, as I explained earlier, what does it mean and all. So in this mouthpiece, since there is no sudden enlargement of the jet, therefore the loss of energy is less. In this mouthpiece there is no sudden enlargement of the jet, so therefore the loss of energy, the energy get lost here. Okay, so here CD into A into root of 2GH. So this is the equation what we get. Okay, there will be a loss of energy here. Next, internal mouthpiece running free. So internal mouthpiece, as the name itself indicates, if the projection is inside the tank, if the tube is projected inside the tank like this, it is called as a internal mouthpiece. If the length of the tube is equal to the diameter, means this length, whatever the length is equal to the diameter of the diameter, then the jet of liquid comes out from mouthpiece without touching the sides of the tube if the mouthpiece is known as running free. So it is internal mouthpiece. If projection is inside, it is called as the internal mouthpiece, but running free means if the length of the tube is equal to diameter, so this L, length of the tube, is equal to diameter, first one, then the next is the jet of liquid comes out, whatever the jet of liquid is coming out through this tube which is not touching the sides of the mouthpiece, just it is coming like this straight, so without touching the sides of the tube, then the mouthpiece is known as running free. See, look here, so here there is no liquid completely filled, it is completely vacant, this space is completely vacant. This jet is not touching the sides of the tube, hence it is called as a running free, that is mouthpiece with running free. So the mouthpieces will be like this, just look here. So these are the mouthpieces, cylindrical mouthpiece, and this internal mouthpiece is also called as a Borda's mouthpiece. It is named after the one who has invented this type of a mouthpiece. It is called as a Borda's mouthpiece. The equation for this mouthpiece again is Q equal to CD into A into root of 2GH, because AQ equal to A into V. Then internal mouthpiece with running full. See, running full means so it was earlier was running free, means where the jet was not touching the sides of the tube. Here running full means, so the first condition is the length of the tube is 3 times its diameter. First condition is, if you take the length will be 3 times its diameter, then the jet of liquid whichever is coming out from the mouthpiece touching the sides of the tube. The earlier one was not touching the sides of the tube, but here it is touching the sides of the tube, hence it is called as a mouthpiece running full. So see, it's an internal mouthpiece only, but it is projecting inside the tank, hence it is called as an internal mouthpiece. And in this case the length of the tube is 3 times the diameter of the tube. If the length of the tube is 3 times the diameter of the liquid jet of 3 times the diameter, then the jet of liquid comes out from the mouthpiece touching the sides of the tube, then the mouthpiece is known as running full. Again the equation is remains same, Q equal to CD into A into root of 2GH. Then what are the difference between orifice and mouthpieces? See, look at the differences here, orifice and mouthpiece. Orifice is a small opening of cross section provided at the bottom of the tank through which the liquid flows. Then a mouthpiece has a length of about 2 to 3 times its diameter, which is fitted to a tank containing a liquid just to increase the discharge. Second difference is, it is used for measuring the discharge of liquid, and it is also used for measuring the discharge of liquid. Then it can be an opening of any type of cross section. It could be a circular, rectangular, triangular, you can take it as square. But mouthpiece, it is a tube which is circular, you can write it as circular or cylindrical. Losses are more here. In orifices the losses will be more, means the energy loss will be more here, losses are less compared to the orifices. So it can be a discharge free, partially submerged and fully submerged. If you the classification, if you based on the classification, if you want to differentiate, it can be a freely discharged or partially submerged or fully submerged, and it can be a short tube, convergent mouthpiece, and convergent divergent mouthpiece, and Borda's mouthpiece. Borda's mouthpiece means internal mouthpiece, and these convergent or the convergent divergent mouthpiece are external mouthpiece. External means the tube which projecting outside the tank is called as external mouthpiece. If the tube is projecting inside the tank, it is called as a internal mouthpiece. Okay, even you can draw the figure for differentiating the orifice and mouthpiece, but remember both devices are being used to measure the discharge through the tank. And here, depending upon the situation and depending upon the condition where you are going to measure the discharge and all, based on that these two different devices are being using. Okay, just extension of orifice, what we call as a mouthpiece, and orifice is a just opening or a circular opening which is fitted at the bottom of the tank or at the side of the tank. Okay, so these are few differences about orifices and mouthpiece. Okay, I hope you all understood these things. And many a times in exam they will be asking the difference between orifice and mouthpieces, and even just classify the mouthpieces. So detailed classification about the mouthpieces and all. So for classification of mouthpieces, just you write that like this, according to the shape: cylindrical, convergent mouthpiece, or convergent divergent mouthpiece, and according to the position, internal mouthpiece, external mouthpiece, according to the nature of discharge, mouthpiece running full and mouthpiece running free. Okay, so these are the some classification made for the mouthpieces. Okay, right. Thank you.